Survival and reliability may sound like very different fields, but there are many similarities. If one is about patients, the other is about machines, but both ask the same question. How long until an event happens? Whether it is the lifespan of a patient or the lifetime of a product. Statistics gives us the tools to measure and predict it. Hi students and faculties, I am Dr. K. Muralidharan, a senior professor of statistics working with the Maharaja Sahajirao University of Baroda. In this video, I will elucidate the concepts of survival and reliability functions with their structural differences. Both deal with the time to event data, that is the time until some event happens, but they are applied in different domains and use slightly different terminology. So one has to take some care about the interpretation of both survival and reliability. Survival analysis is about living things and their time to event, whereas reliability analysis is about systems or components and their time to failure. So that naturally happens in engineering applications and the lifetime experiments, etc. So the interpretation depends on the context of studies. So one has to be very careful about it. So let us look at the comparison. Survival studies, the domain is generally medicine, biology, social science, etc. Whereas reliability studies, the domain is engineering and manufacturing. Data type you are talking about, it is survival studies, most of the time it is humans or animals. Okay, where we usually talk about the survival of humans and animals. Whereas reliability studies, it is we always talk about machines, product data, etc. And the event correspond to survival data are death, disease, recurrences, recovery, etc. And reliability studies, most of the time we look at the failure of component or items or systems. And the measures generally used in survival studies are survival probability, hazard functions, etc. Whereas in reliability studies, we talk about reliability function, hazard functions, failure rate, etc., etc. But there are, you see, hazard function in both the cases same, but the terminology and the interpretation goes in a different way. The terms generally used are hazard ratio in survival studies, survival curve sometimes, median survival time sometimes. And in reliability studies, we often talk about mean time to failure or average time to failure or mean time between failure, etc. And the methods, the most frequently used methods in survival studies are Kaplan-Meier estimation, Cox regressions, etc., etc. So they are semi-parametric approaches. And reliability studies, very often we talk about exponential analysis, Weibull analysis, gamma analysis, life data analysis, etc., etc. So there is a difference. So let us look at the distributional properties. Suppose we have a non-negative random variable x, which denotes the lifetime or failure time of a unit, which has distribution function capital F of t and density function small f of t, which is nothing but derivative of capital F of t. Then the survival distribution or reliability, because they are same. So the notationally they are same, but the definition wise they are same, but notationally there could be some difference. So probability of x greater than t, both are denoted as probability of x greater than t, which is equal to 1 minus f of t. It can be expressed in the integral form as well. If ht denote the instant failure rate, then h of t is f of t divided by f bar t. And you can see that f of t density function can be a product of two things. You can write it as ht and survival function. So it's always possible, provided the distribution function is closely defined. And we also have cumulative hazard function. Many often we talk about cumulative hazard function in survival studies as well as reliability studies. So, and it's very well connected with the reliability function in the form RT as e power minus integral 0 to th of u du h of u du. So that can be further expressed in terms of cumulative hazard functions. So you can see that f of t, rt, small ft, ht, and h of t determine one another. If you know one of the quantities, you can determine the other one. And the mttf is nothing but the mean time between failures, mean time to failures, that is expected value of x. So that is integral 0 to infinity expect tf of t expectation, simply expectation. So survival time versus mttf. Let us see that. So why medicine or medical studies use medical median survival time? So most of the time, if you see the survival of patients, survival of human, I mean animals, of this kind of experiments, most of the time you will get skewed data. That is the most important aspects of survival studies. Survival times in patients are usually right skewed. So generally, because many often the objects or the units under study may not be available, so they may have different lifetimes altogether. Censoring is another concept which is very often used in clinical trials. And of course, clinical interpretability itself is a very important problem. So doctors generally say half of the patients survive at least 12 months. So they generally don't go for any abstract measure of mean or average or something like that. So easy to understand for patients and policymakers if this kind of statements are generally done. Whereas engineering people usually talk about mean time to failure and mean time between failures. So they use these kind of quantities for predictive planning, and many often the distributions are not often well defined. So, okay, failure times, even hazard your distribution functions may not be well defined. So you will have to work with some, I mean, quantities like MTTF and MTBF. And system level reliability. In reliability engineering, averages are easier to use probabilistic risk assessments and maintenance schedules. So, medicine favors the median because of survival data, because they are messy, censored, and skewed. Whereas engineering favors the mean because the components we often consider are lifetimes. Okay, so that can be associated with some probability models, and we can always talk about averages. So there is a basic difference as such. So the context is important. Where do you apply? Whether it is survival studies or reliability studies, accordingly you will have to interpret the whole thing. Okay, so let us look at from a real life strategy, our real life analogy. Imagine you are tracking 100 cancer patients. So in a survival study. So many often 100 the patients, some may pass out away immediately. Some may live for a short period of time. Some may live for a long period of time. So that is generally happening in the survival studies. If you took the average of this, then definitely it is going to inflate the whole measure. Okay, so we cannot make a favorable decision based on that. So doctors report the median survival rather. Half of the patients live at least 12 months. So people looking at the data, they may say, so this is fair and interpretable and not distorted by outliers. So median, we know it's not, I mean, affected by extreme values. Now think about 1,000 medical light bulb, identical light bulbs. So most of them fail around the same range of hours. We can always see that once the experiment starts. So you just record what time the failure is happening. And so the failure pattern is predictable. The average lifetime makes sense. So the engineers say the mean time to failure is 5,000 hours. This is useful for planning warranties, inventories, and replacement schedules, etc., etc. So for patients, we care about what is typical. So we always look at what is typical, whether for a cancer patients, people or the doctor will be always, I mean, looking at which actually dominated the patient's death, patient's recovery, etc., etc. So what is typical? That is median. So always talking about median. So the best measure is median. Whereas in machines, when you talk about, we say what is the expected averages, okay, what is the expected lifetime, okay, what is the average lifetime, etc., etc., something like that. So MTTF or MTBF. So the terminology may sound same, look same, but the application part, if you see, totally different. So you don't confuse with the survival function and reliability function when you apply. Okay, here are some more properties. So f of t we have already seen. So you can always make it as a product of two functions, a hazard function and distribution function. 1 minus f bar t means 1 minus f of t. Okay, and instant failures rate, okay, that can be easily found. So if you know one of the quantity, you can see the other way. So interval failure rate can also be defined as t to integral t to t plus x, 1 by x h of u du. It can also be expressed in a 1 by x log by f bar t divided by f bar t plus x. Failure rate, of course, is nothing but the instantaneous failure. So as limit goes to some small zero, so what is going to be that? So that is what is called instantaneous failure rate. Okay, so you can also express that in terms of cumulative sort functions, etc. Okay, so those quantities are very, very important for modeling purposes. So, so what are the takeaways? Whether it is people or machine, survival and reliability analysis teach us how to measure, model, and improve performance over time. Now, although they may come from different worlds, they share the same mission: understanding how long things last and how we can make things them last long. So please see the importance of the studies, apply according to the context and situations. Okay. Thank you very much. Yeah, you can watch some more videos which are about to come. Thank you very much.